the unit circle. In order to understand this lecture, you should be familiar with the following triangles. We have right triangles where we have a 45-degree angle, a 30-degree angle, or a 60-degree angle as indicated in the illustrations. These special triangles were covered in my video on the Pythagorean theorem. And we're also going to be borrowing from the previous lecture the following formulas. We have r equals the square root of x squared plus y squared, where xy is simply a point in any one of our quadrants. So here I have it drawn in quadrant 2, but it doesn't matter where it's drawn. As long as you know the values, that is the coordinate values for x and y, you can find your values of your trig functions. And in this class, we're going to look at the special and very important condition where r is equal to 1. So I have these formulas from the previous slide, and please notice that if r equals 1, then the sign will just be y, because it'll be y over 1, which equals y. Similarly, cosine will be x over 1, so it's just x. Now the tangent, there will be no change. Since it doesn't involve r, it will still be y over x, as shown here. Now, what you're going to discover is that this is an excellent way of organizing some basic values that occur frequently in trigonometry. So we're now going to use these three formulas and look at some special angles. First of all, what are known as quadrantal angles. These are simply angles which coincide with your x or your y axes. So for instance, if we had a 0-degree angle, it would essentially be coinciding here with the positive x-axis. Now, if r equals 1, then notice that this point over here, where the x-axis intersects the circle over here to the right, that the coordinates of that point would be 1, 0. We know it's 1 because the radius, that is the distance from the center to the outside of the circle, is 1. Similarly, if we had a 90-degree angle, we would be at this point, which would have coordinates of 0, 1, 180 degrees, would have the values -1, 0, and finally 270 degrees would have coordinates of 0, -1. Notice how easy it will be to determine our trig values. For instance, if I ask, what's the sine of 90 degrees? If you know these values, and you simply look at the coordinates at 90 degrees, 0, 1, and the sine is supposed to equal the y value, so it would be equal 1. You know, cosine of 270 degrees, that equals the x value for 270 degrees. And notice the x value there would be 0. Tangent would be easy enough to do also. We would simply form a fraction with these values. Next, I've indicated here as green lines 45 degrees, 135, 225, and 315. And let's look at the 45 degrees. If I drop a vertical line down here, I form a right triangle. And I've reproduced the special right triangle that we'll be using for this problem. Notice that the x value here would be square root of 2 over 2. And this also, the y value would be square root of 2 over 2. So the coordinates there would be square root of 2 over 2, square root of 2 over 2. Notice if I said, what is the sine of 45 degrees? You'd look at the y value would be square root of 2 over 2. The cosine would, of course, also equal square root of 2 over 2. What would be the tangent of 45 degrees? Well, it would equal y over x. But if you do square root of 2 over 2 over square root of 2 over 2, of course, that just equals 1. Anything over itself is 1. Now, I'd like you to notice that this 45-degree angle, that 135 is 45 degrees away from the x-axis also. we say that 135 has a reference angle of 45 degrees because it's the same number of degrees away from the x-axis. Similarly with 225, that's 45 degrees away from the x-axis. 315 is 45 from the x-axis. And the significant thing is that they will all have the same x-y coordinates with the exception of the positive or negative sign. So for instance, for 135, since that's in quadrant 2, we know that the x value should be negative and the y value should be positive. We just know that from algebraic graphing. At 225, that's in quadrant 3. Both values would be negative there. And for 315, notice that while your x value would be positive, your y value could be negative. Let's do the same thing with these angles. 30, 150, 210, and 330. The 150, 210, and 330 all have reference angles of 30 degrees because they're each 30 degrees away from the x-axis. So borrowing from our special triangle, please notice that the coordinates here for 30 degrees would be the x value from that triangle. That would be square root of 3 over 2. And the y value would be 1/2. All we have to do now is reproduce these values but change the signs to suit the quadrant. So quadrant 2, x is negative. Quadrant 3, quadrant 3, x and y are negative. And in quadrant 4, the x is positive, the y is negative. So cleaning that up a bit. There we go. For 60 degrees, look at the triangle over there to the right. And notice that the x, that is the horizontal side, would be 1/2. The vertical side or y side would be square root of 3 over 2. Please notice that these other angles are all exactly 60 degrees away from the x-axis. So for instance, from 120 to the x-axis, that's 60 degrees. So again, all we have to do is make the appropriate changes in signs. And there we are. These values, which we just ran through, have all been reproduced on this illustration. Now it looks a bit overwhelming because a minute ago we just looked at a few of them at a time. All students of trigonometry, in my opinion, will serve themselves well if they memorize these coordinates with the various angles. However, think about the way I've been showing this to you. There's not really that much to memorize. What you really have to do is memorize all of those coordinates for quadrant 1. Because after all, once you know those, you realize that in the other quadrants, they're the same values with changes in the sign. So in quadrant 2, the x value's negative. In quadrant 3, x and y are both negative. And in quadrant 4, the y value is negative. In fact, I said it's a good idea to memorize these. This is actually the chart that I'd recommend that you memorize. I would recommend that you do it for the radian values rather than the degree values because they occur much more frequently in trigonometry. And after all, there's a way of converting from radians to degrees anyway. So take the time to learn this. It will definitely help you out. Let's just finish with perhaps an example or two using this diagram. If I were to ask now, what is the sine of 7 pi over 6? We would search for that angle, and the sine would equal the y value. If I said, what is the tangent of 7 pi over 4? We would look for that angle. We know that it should be y over x, and that would just equal -1. They're not identical, but they're opposites of one another. All right, that's it. Good luck.